So we already know what's on the screen here, that if we take a limit and they don't agree from the right side and the left side, if they don't come together in the same spot, then it doesn't exist. We know if they're going up forever or down forever, that we're going to say it doesn't exist, but at least we could say infinity or something. And if it oscillates, if you remember last time we talked about the oscillation at that point, if it's going back and forth forever, back and forth as we get closer and closer to that, and it never settles down on, either positive or negative, but it's oscillating, there's no limit there. So we know these three things already, and hopefully this is so painfully obvious that it's just painful, but not difficult. So as x approaches c, and we have f of x, we just replace what we're getting close to, and that'll give it to us, okay? As long as it's legal, we're okay. The trouble is when it's not legal, but anyway. If I have a constant here, and I say, hey, x is getting close to c, b says, hey, I'm a constant, I'm 5, I don't care what x is doing, I'm still going to be me. And then here we go. For 2, 3, and 4, we're just saying it's the same thing. As x approaches c, then guess what the limit is? It's c. And as x approaches c, it's going to be, instead of x, it's going to be c, but it's the same thing. So we're just plugging it in. We're just plugging it in. That's all we're doing. The properties of limits, they are the things that you would guess that they are. They're the things that you would want to be the case. If I take the limit as x approaches c of a function times b, it's okay if I just do not b and just the function, and when I get the limit, then I multiply by b. So I can factor the b out, if you will. If I take the limit as x approaches c of f of x and g of x added, it's okay if I do each one individually and then add them together. If I actually add their limits together instead of adding the functions together. It'd be easier if I just found each limit and put them together once I found the limit. Maybe it'd be easier. Again, if I find the limit as x approaches c of f of x times g of x, it's okay if I find their limits and multiply them together instead. If I take the limit as as x approaches c of f of x divided by g of x, it's okay if I just take their limits and divide those instead. And same thing with the power. I can wait till the end and put the power on the limit if I would rather. I don't have to take into consideration the power while I'm finding the limit. That's really helpful. So here's direct substitution. I'm wondering what happens when x is getting close to 4. We'll plug 4 in and see what happens. You get 16. What happens when x is getting close to 5? Well, close to 4. I plug in 4 and see what happens. I get 20. Okay, that's it. Here I say I could take the limit of the top part and divide it by the limit of the bottom part, and it turns out I get 0. Here's where I just plug it in. I plug in a 9. I'm all good to go. Here I would rather do this in this piece first and then this piece, so I do it. I say the limit over here times the limit over here. That's what you would kind of hope. You would hope you could do that. Like you could distribute the limits, kind of like you're distributing the limit, like to this one and then to this one, and then you multiply. If that's how it makes you, if it helps you think of it that way, that's fine. Because that's what happens when we put it together like this. Exactly like you would think. So let's go ahead and do this. Let's say, what is the limit? The limit as x approaches 2 of f of x. Well, that's going to be equal to, I'm going to plug in 2 for f of x, and I'm going to get 2 to the third, which is 8. So the limit is 8. That's called direct substitution. Just put it in there and see what happens. Okay, and then the limit as x approaches 2 of g of x. well, what's going on here? Well, guess what? I'm going to plug in 2 to this and see what happens. And I say 2 squared plus 5, square root of that, over 2 times 2 squared. Alright, well, that's 4 plus 5 is 9, the square root of 9, over 8, right? And so then I'm going to say the square root of 9 is 3, so I guess I better say plus or minus, should I say that, over 8. And I think I'll just keep it to, yeah, I think I will do that. And then I'll say, hey, by the way, let me get rid of the plus or minus. If it's not necessary, I'm just going to keep it positive. We kind of assume that when we need to. So we'll say, what's the limit then, as x approaches 2, of these functions multiplied? You're like, oh, I have to multiply the functions together. And no, you don't. You can just multiply their limits together. So 8 times 3 over 8, the 8's cancel and I get 3. I don't have to actually do that because I know the limit of each one. And I can multiply them together instead. The limit as x approaches 2 of g of x minus f of x. So what's the limit of g of x? Well, it's 3 over 8. And I am subtracting 8 over 1, let's say. So I'm going to get a common denominator, I suppose. And I will say, well, this is a little tedious, I guess, but it's not too bad. Minus 64 over 8. So that's negative 61 over 8. Okay? So these are my answers. I think you'll agree they're not too bad. I hope you'll agree. Oh, yeah, okay. So you have a sine. You have a trig function in yours. So you have to think about, sine of 2 pi a lot. If x is going to... Can you do that? I think you can do that. Okay. There we go.